In lesson 4.3, we're going to look at a couple of different types of sampling methods, some that are good and some that are bad, and talk about what makes them different and why some are better than others. And to illustrate these sampling methods, we're going to try to estimate the average word length in the Gettysburg Address. Now, the Gettysburg Address is pretty long. In fact, there are 268 words in the Gettysburg Address. So, what we could do is we could go through it and count up all the letters in all of those words and actually calculate an average. But because that's very time consuming, we're going to use sampling to try to estimate the average word length. So, essentially, what we're going to do is we're going to select some words using a couple of different methods. We're going to calculate the average from our sample and then look at many different averages to see if we can get an idea of what the true average might be. The first thing we're going to do is we're just going to quickly circle a random sample of 5 words, and you're going to pick those 5 words. So maybe kind of look through the copy of the Gettysburg Address that's in your note packet and pick out 5 words that you think represent the average or typical word in the Gettysburg Address. So this is what the Gettysburg Address looks like. And so what I did is I went through and I circled these words. I circled dedicated, sense, living, measure, and shall. And you can do this for your own set of 5 words. So I'm going to write down the 5 words that I picked. And then in each of those words, I'm going to count the number of letters in those words. So when I count up the letters in dedicated, for example, there are 9 letters in that word. Sense has 5 letters, living is 6 letters, shall is 5, and measure is 7. So I added up all the letters in each of those words. I divided by 5 to get my average, and my average word length is 6.4 letters per word. What I would do then on my dot plot is I would put a dot at 6.4, which would be right there. And you can do the same thing for your average. And then because we're not in a traditional classroom setting, what I'm going to do is show you the dot plot that I got from a group of 25 students when we conducted this activity last year. And you can go ahead and pause the video and copy down that dot plot. Now you notice when we look at these results that a lot of them were pretty similar. We did have one student that just selected really short words. So they went with all words that were 3 or 2 or 4 letters because they didn't want to do a lot of counting. But in general, most of the results were from about 4.5 up to maybe about 7.2. And I would say that probably the typical value or the center of this distribution was right here at about 6. So we could say, based on this dot plot, that the average word length in the Gettysburg Address might be somewhere around 6 letters per word. Now we're going to take a different type of sample. So in our next example, we're going to do a sample using a random number generator. Now, the way that this works, you can do it on your graphing calculator, is you're going to hit the math button, which is over on the left. And then when you get into that math menu, you're going to scroll all the way to the right to the menu that says PRB, which stands for probability. And you're looking for the function that says rand int. That will have the calculator select random integers for you. Once you select that, you need to tell it that you want to pick a random integer between 1 and 268 because there are 268 words in the Gettysburg Address. And when I did that and I hit enter, I got 55. And then I hit enter again and I got 264 and then 195. And I did this 5 times. Now, if you try this on your calculator and you get duplicates, like let's suppose maybe 55 comes up again, you're going to need to select another integer because we want to get 5 unique or different random integers in our sample. Now that 55 represents, we have selected the 55th word in the Gettysburg Address as part of our sample. And you also have access to a handout that looks like this, which has all of the words in the Gettysburg Address in order, and they're numbered for you to make it very easy to find the words in your sample. So for mine, for instance, my first word that I selected was 55. The 55th word is we. So that would be the first word in my sample. And you can try this on your own calculator and go through and pick out the words that are in your random sample. And then just like we did with our first type of sample, we're going to write those words down. So these were the words that I ended up with. We're going to count up the letters in each word and add them. And then we're going to divide by 5 to figure out an average word length. So in my second sample here in question number 4, I ended up with an average word length of 4.6. Now, remember, in my first one, my average was quite a bit larger. It was 6.4. Now, when I did this with a class of 25 students, this was the dot plot that resulted. And notice we still have a couple of extreme values. Like we had one student that ended up with an average word length of 2.8 and somebody that was way up here at 6. But in general, the averages tended to be lower. In fact, if we looked at kind of the center of this distribution, we would probably say it's right here at about 4.5. Um, and you may be wondering at this point, what is the actual word length, average word length in the Gettysburg Address? And as it turns out, the true actual average is right here at about 4.29 letters per word. So why did our random sample give us better results than our first sample, which we call a convenient sample? Well, with a convenient sample, what we tend to do is we tend to pick longer words because they stand out more to us on the page and they're easier to spot. With a random sample, we're more likely to get a mix of short and long words, which is probably a little bit more representative of what is actually in the Gettysburg Address. So we can see that our first sampling method resulted in what we would consider to be bias because we're overestimating the average word length. Our second sample, which was a random sample, gave us much more accurate results and a better estimate of the value that we were trying to guess. So how is the dot plot in number 5 different from the one in number 3? In the center of the dot plot in number 3 is higher than the center of the dot plot in number 5. So we had an overestimate. So what we've done here is we've illustrated a couple of different types of samples. First, we have what's called a convenient sample. And a convenient sample, as the name implies, is when we choose the people that are easiest to reach. For example, if you need to conduct a survey for a class like WOBN, for example, and you go out and you just ask your friends to take your survey, that's the easiest thing for you to do. So we consider that to be a convenient sample. And this often has bias because your friends are likely to have the same opinions you do. We also can conduct what's called a voluntary response sample. And in a voluntary response sample, people volunteer to participate. This happens often in internet surveys. If you are ever on a website and they have the survey there and they ask you or invite you to click on a link to complete the survey, this would be an example of a voluntary response sample. Now, a random sample is where we use chance to pick participants. And this is the only way to ensure that we have no bias in our sampling. An example of this would be random phone dialers. If a county or a government agency wants to take a random sample of everybody that lives in the county, they might use a random phone dialer where a machine or a computer would generate random phone numbers and they would use that to call everybody. And then that way we are giving everybody kind of a fair chance to participate. Now, the term bias in statistics means that we are either constantly over or underestimating the truth. So, if you think about our example with the Gettysburg Address, when we picked the words that we thought were typical, we picked longer words than what the true average word length was. So, we overestimated the average word length because our method was biased. In our example here, let's say that during a Monday Night Football game, the referee made a controversial call, which resulted in a touchdown being taken away from the Detroit Lions. The next morning, the host of the sports radio show was discussing the game and invited listeners to vote online and answer the question, should the Lions have been awarded the touchdown last night? 2,407 people, or 85%, said yes, and 410 people, or 15%, said no. So the type of the sample that the radio host obtained here was a voluntary response sample because he invited listeners to vote online and they participated voluntarily. The reason this sampling method is biased is because people with strong opinions are most likely to take the survey. If you really don't care that much about Lions football, you probably aren't going to take the time to log into your computer and take the survey. But if you feel very strongly, you probably will take the time to log in and complete that and voice your opinion. Is the 85% likely to be greater or less than the percent of all adults who believe the Lions should have been awarded the touchdown? I would say that this is probably higher. Again, because the diehard fans who are really angry about the call would probably be the ones that would log in and complete the survey most. Now, how the radio host could have avoided bias that we described above is that they maybe could have randomly selected people to call and ask. This way, you would probably get a mix of people who really care about the Lions and some people who don't care about the Lions. And then maybe you would get a better picture of what all people think, not just getting the opinions of the diehard Lions fans. Please do assignment 4.3 in your homework packet.